Hi, welcome to this code walkthrough where I'll just be talking through the code for my simulation. Just briefly talking through what all the components do and how they interact with each other, just to give an overview of my code and how it works, as well as a brief overview on the interface and how one uses that. So let's just begin at the top. We have class organs, which can be called and allow me to cycle through my different organs, which I can call later down the code. It doesn't really do anything on it by itself. Here I have class organ, which is the superclass for all my other organs, which defines all of the variables and all of the getter and setter variables for all my organs class. And as this is the superclass, it also defines all of the universal calculations excluding heart. So here we have my Tortilli's law equation, which calculates the flow out of each organ of each iteration. Here we can see the heart class. The heart class is the only organ class which differs as it has more than one exit radius. So it needs its own autoregulation class, which is seen here, which is almost identical to the normal autoregulation class, except it cycles through its radius exits with this little I, using for ion range. And same with the blood flow equation. It is almost exactly the same, except it cycles through the flow outs. Then we have the different organ classes, all of which identical, just defining the organs with taking the superclass from organ. So here we have one for the gastrointestinal, kidney, the skeletal muscle, brain, the integument, and then the others organ. Here we have the simulation class, which defines the values for all the organs. So here we have the volumes, which are permanently set, and they are to represent the size of the organ as it would be in the body. And here we have the flow outs, and you can see there are 6 for the heart, whereas there's only 1 for every other organ. And then we have the getter and setter methods for each. And here we have the universal calculations. We have autoregulation, the autoregulation class, which is designed to cause vasodilation or vasoconstriction for each of the organs, depending on whether the variables fall within a certain range. The neural regulation works similarly, and so does the endocrine regulation. And then we have a check for live function, which essentially makes sure that all of the values are within a certain range, and if they are not within a certain range, the body will fail and end the simulation. So simulation is set to false, and a message is printed detailing why the simulation ended. And then we have a heart flow in class, which calculates the flow into the heart by adding up the flow out of all the other classes. And then we have an organs flow in, which sets the flow in to all the organs by calculating that, times by 1 is yep. And then we have the run simulation class, which takes the runtime, applies it to this, so we'll run the simulation for that many times, just calling all the different regulation functions. And then here we have the shell output, which outputs all of the different values for all of the different iterations. And then we have the GUI class, and then we have the code linking the GUI to be able to set the parameters yourself. So then when we run the code, we're met with the GUI, where you will first want to select an organ, whichever one you want. Let's go skeletal muscle. Then you can input values. These will just be rudimentary values. And then you can enter values, and then you can see on the output, skeletal muscle has been selected, and then the oxygen level has been set to all of these. And then you can do this for the other muscle. Let's go heart. You can change these values. Enter the values. And then you can do that for every single organ. And then you can press start. And you are met with this. And then you input how many iterations you want the simulation to run. And then it will run.